So probability section 3. Probability is a bit of a misnomer today because we're not doing a whole lot of success over total outcomes. We're actually going to do a lot of counting today. So we're going to talk about the multiplication counting principle. So if there are m ways to make the first selection and n ways to make a second selection, there are m times n ways to make the two selections. I know without context that really doesn't have a whole lot of meaning to you. So turn to example 2, and this will make a whole lot more sense, I think. Okay, here we go. Actually, yeah, let's do example 2 first. Okay, so on a map, there are 2 tunnels for cars going from New Jersey to Manhattan, and 3 bridges from Manhattan to Brooklyn. How many routes using a tunnel then a bridge are there from New Jersey to Brooklyn through Manhattan? So we know that we have 2 ways to go from New Jersey to Manhattan. And then we have 3 ways to go from Manhattan to Brooklyn. So 2 tunnels times 3 bridges. There are 6 routes. So that would be the way that you do it using multiplication. Let's talk about it real quick using what's called a tree diagram. So the tree diagram says, so suppose you have 3 shirts and 2 pairs of pants that coordinate well. I don't know, say like a uniform. Make a tree diagram to find the number of possible outfits you have. So let's take a look at this. You have 3 shirts. 1, 2, 3 shirts. So if you choose shirt 1, then you could choose either pants 1 or pants 2. So shirt 1 could go with pants 1 or pants 2. Well, if you chose shirt 2, you could also choose pants 1 or pants 2, and then shirt 3 is the same thing. So you could choose shirt 2, pants 2, or shirt 3, pants 1. So these are all the different ways you could pick. So we've got 1, 2, 3, 4, 5, 6 ways that you could make an outfit. Well, let's think about this again. There are 3 shirts and 2 pairs of pants. 3 times 2 is 6 outfits. So that is the visual representation of how this works. Okay? All right, so let's talk about permutations. That's a very fancy, fancy word. All it means is that you're taking things and arranging those objects in a very specific order. Okay, so the notation is NP, little n, big P, little r, and the n and the r are subscripts. So NPR, P standing for permutation. N is the number of objects that you have to pick from. R is the number that you're picking at a time. So let's take a look at an example of what that might look like. So let's take a look at the baseball example, example 3. How many different batting orders can you have with 9 baseball players? So you have, does order matter when you're making batting orders? Absolutely, right? You want to have your 4th, right? You want your 4th strongest batter, or your strongest batter to be in the 4th position. Like there's a lot of strategy when they make batting orders. So that tells me this is a permutation because order is going to make a big difference. Okay, so how many players do we have? We have 9. So that is our N. N equals 9 players. How many players are we putting in our batting order? Well, we have to put all of them in, right? So R equals 9. So if we're going to use that notation that we just looked at, it would be 9P9. Okay, so back to our notes. So we have N objects arranged R at a time. So in this case, we did 9P9. So what does that mean? Permutation is an operation. It means we're doing something. So we're going to have N times N minus 1 times N minus 2, on and on and on until you get to all the way to the end. So for instance, 9P9, we have 9. N is 9. And then we multiply that by, just subtract 1 from it, so by 8. And then we subtract 1 from it again, so 7. And then 6, and then 5. And we do this 9 times, so 1, 2, 3, 4, 5, 6, 7, 8, 9. We just happen to get all the way down to 1 in this case. It won't always be that way. And then you multiply them all together. So let's do it in this example. We have 8p3. So here we go. We start with n, which is 8, subtract off 1, and then keep subtracting 1, 7, 6. And then how many times do we do it? We do it 3 times. So 1, 2, 3. Oh, we're done. So you multiply 8 times 7 times 6, you get 336. All right, so for this example 3, we actually already kind of did it. It was 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that's a really big, big, big number. All right, let's look at the quick check. A swimming pool has 8 lanes. In how many ways can 8 swimmers be assigned lanes for a race? So our n equals, how many swimmers are there? I'm sorry, lanes, number of lanes. And then how many swimmers are there? So we have 8, pick 8, because does it matter which lane you go in? Absolutely, right? The side lanes, they say, are slow and the middle lanes are faster. Okay, so we've got 8 times 7 times 6 times, okay, we keep doing this 8 times, right? So multiply those all together, you get a really big number. All right, how about 7p4? Let's do that example. So how would we do this one? Start with 7 times 6 times, how many times do we do it? We do 4 numbers, so 1, 2, 3, 4. They just happen to match. That doesn't always happen, guys. Like, this didn't happen here. So 7 times 6 times 5 times 4, 840. All right, try 9p3. That's my oldest child blowing his nose. All right, here we go. We start with 9, and how many numbers we're gonna get? 3, right? Times 2, so 9 times 8 times 7. How about 7p3? We start with 7. How many numbers? 3 numbers. So 7 times 6 times 5. All right, how about the last one, 5p2? What do we start with? 5. How many numbers? Just 2, so 5 times 4. All right, those are your last examples on the example sheet. All right, so that is permutation. So like I said, there is not any probability in this section yet. We might get to some. This is more counting. How many ways can you do certain things? So give a shot to that page and that page. The answers are on the last page, okay? And then, or last pages. And then we will meet, and you are welcome to ask me any questions that you have. If you want to do some more examples then, we can do that then as well. All right, I'll see you in a while. Bye.